This session is a continuation of the Chapter 1 review, starting with Problem 9. Problem 9 says, plot point A, which is 8, negative 4, B, which is 2, 4, C is 7, 1, and D is 1, negative 8 in a coordinate plane, and then determine whether AB and CD are congruent. Okay, let's go ahead and bring up a coordinate plane, and then we can go ahead and plot our points. So we have 8, negative 4. So let's make sure we have our chalk selected. 8 and negative 4, which is here. We have 2, 4. 2, 4, which is here. We have 7, 1, which is here. And 1, negative 8. 1, negative 8. Okay, so this is point D, which is 1, negative 8. This point is B, which is 2, 4. We have 7, 1, which is C, 7, 1. And point A, which is 8 and negative 4. So negative 4. Okay, now we're looking for AB. So let's go ahead and draw a segment from A to B. So there's AB. And then we have CD. So let's go from C down to D. And we're charged with determining if these two are congruent segments. So here we're going to do distance formula twice. So I want to get rid of this little mark in here because it looks kind of ugly. Okay. All right. So 2, 4, 8, negative 4. So 2, 4, 8, negative 4. We're going to use distance formula, of course. 2 minus 8 is negative 6. 4 minus a negative 4 is 4 plus 4, which is 8. SAS, square, add square root, and we have 6 squared is 36. Negative 6 squared is also 36, plus 8 squared, which is 64. Which gives us square root of 100, which is 10. Now let's do the other 2 points. So we have, there's supposed to be a parenthesis there. 7, 1, and 1, negative 8. 7 minus 1, 6. 1 minus negative 8 is 1 plus 8, 9. Square, add square root, SAS. So here we have the square root of 36 plus 81, which is the square root of 117, which is approximately 10.82. And so we can say no, they are not congruent, because congruence means they have equal lengths, so these are not equal in length. And now on to problem 10. Problem 10 states the endpoints of AB are given find the coordinate of the point P that partitions the segment in the given ratio. Then find the coordinate of the midpoint M of segment AB. So here we have a set of coordinates 2 and 22 and a ratio of 1 to 3. So the first thing we want to do is let's go ahead and create a segment. So here we have segment AB with coordinates 2 and 22. Now what this is asking us to do is to find some point between A and B, called P, that breaks this piece up so that there is 1/4 of it from A to P and 3/4 from P to B. So in order to do that, we're going to break this segment into 1 plus 3, 4 equal pieces. So let's go ahead and do that. Okay, so I've broken it into 4 pieces. They don't have to be perfect, it just has to be an approximation. Now we need to have point P positioned so that 1 of the 4 pieces is from A to P and 3 from P to B. So here is a point where there's 1 from A to P, so we're going to call P right here, and 3 from P to B. So 1/4 is from A to P, 3/4 from P to B. Now that's all that remains is for us to find the coordinate of this point. The way we're going to do that is we're going to find the total length of this segment and divide it by 4, which gives us the length of each one of these pieces. So to find the total length, we're going to use the ruler postulate. The ruler postulate says the length of any segment on a number line is the absolute value of the difference of the endpoints. So the absolute value of 2 minus 22, which is the absolute value of negative 20, which is 20. So the length of this segment is 20 units long. Now, in order to find the width of each one of these pieces, we divide 20, the total length, by the total number of pieces, 1 plus 3, which is 4. That gives us a length of 5. Each one of these pieces is 5 units long. Now, that's all we have to do is find the coordinate of P. So P equals, we start at A, which is 2, and we're going to the right, so we're adding. We add 5 units, plus 5, which gives us 7. Now let's finish up the problem, the second part. Find the coordinate of the midpoint, M of AB. So midpoint, remember that midpoint is simply the average of the endpoints. So to average two numbers together, we take, let's select our chalk, we take 2 plus 22 divided by the number of numbers, 2. That gives us 2 plus 22 is 24 divided by 2, which is 12. So the midpoint of this segment is going to be at 12. 12 is 2 plus 5 plus 5. So this is going to be point M, which is at 12. Now let's move on to problem 11. Problem 11 is very similar to problem 10, the only difference being that we have a partition ratio of 2 to 1. So here we have a segment AB, endpoints -7, 17, and we've broken it up into 3 roughly equal pieces. We need to find a point P where 2/3 is from A to P and 1/3 from P to B. So here's 1/3, 2/3. So P must go here, and 1/3 from P to B. So now we have to find the coordinate of point P. So to do this, just like we did the last time, we find the length of the entire piece, which is the absolute value of the difference. That's the ruler postulate, -7 minus 17, absolute value, which is the absolute value of -24, which is 24. That's the total length of AB. We divide it by the number of pieces, which is 2 plus 1, 3. So we divide 24 by 3. That gives us 8. So each one of these pieces is 8 units long. So this piece is 8, 8, and 8. So now that's all we have to do is add across. So coordinates of point P, we start at point A, which is -7. We add 8 from here to here. We add 8 more, which equals 9. So the coordinates of point P is 9. Now we want to find the coordinate of the midpoint of AB. The midpoint is given as the average of the endpoints, -7 plus 17 divided by 2, which gives us 5. So the midpoint, M, is somewhere in this vicinity. Midpoint M, which is 5. And so let's move on to problem 12.